Hello boys and girls, and welcome to lesson 1-6 on page 31. We're going to look at order, pairs, and relations, and we're going to look specifically at coordinates and the coordinate planes. Okay, first let's look at a situation of where we would use the coordinate planes. Bungee jumping would be an example. As you can see, people bungee jump from bridges, from cliffs, and even into volcanoes. The table describes 4 bungee jumping sites and the approximate heights and times of the jumps. There are different ways to represent this information. So we have the location of there's a place in Austria, one in Idaho, one in China, and one in Arizona. This is the height from the jumping point to the bottom, and this is the time that it takes to fall. So there's a way to represent this information using a coordinate plane. Before we do that, let's get familiar with the coordinate plane. So a coordinate system, or we can call a coordinate plane, is used to locate points on the y-axis and the x-axis. We always go to the x-axis first and then vertically to the y-axis. So there we go, y-axis. The 0, 0 mark is called the origin, the beginning, the origin. We have the x-axis is the horizontal number line. The order pairs are the numbers, x first and y next. And the first one is called the x-coordinate, and the second one, the y, is called the y-coordinate. Okay, so now we know the language. To graph data such as this one, we can simply set up a range of different heights and the times that it takes to fall, and then we plot it on the graph on the coordinate plane. The x is often also known as the domain, and the y is known as the range. How high does it go, how low? So this is the domain, what we're talking about, what we're measuring, and here is the measurement. Okay, on page 32 we're going to practice placing the order pairs on the coordinate planes. Okay, let's say we're given the order pair J, 5 and 3. We start at the origin, so we start right there at the 0. Since the x-coordinate is 5, we move 5 units. So we always move 5. We always move on the x first, and then the y is 3, so then we move up 3. And notice how it's labeled. Okay, J parentheses 5 3. Okay, and then you just draw the dot there. Let's do K, 0 4. Okay, we start at the origin. Now x is 0. It's not going to move on x at all. X is 0, so it's not going to the right. It just stays put. But y is 4, as you see right there. So with y, we just go straight up, and that's where we end up, and we label it K. This is point K, 0 4. Okay, it's right on the axis, on the y-axis. Okay, if we were to do Q, R, S, and T. With Q, we have 2, 3. So let's find Q. We have 2, we move over 2, and only 3 up. And there would be the 3, the third one right there. Okay? Okay, so let me show you how I graph the rest of them. I'll zoom in to show you. Okay? I've labeled them. You can see that Q is 2, 3. So Q is, we move over 2 and up 3. 1, 2, 3. There's Q right there. Okay, S is 3 and 1.5. So 1, 2, 3, and 1.5. Right there at the half point between those 2 points. Half. Okay, R is 5, 0. So we move 5, 1, 2, 3, 4, 5, but 0 on the Y, so we don't actually move up on Y, so we just stop there. And T, as you can see down here, is 6.5 and 5.5. So we go 1, 2, 3, 4, 5, 6.5. And we go straight up to 5.5. 1, 2, 3, 4, 5.5. So it's right in the middle of this square. Right in the middle there. 6.5 this way and 5.5 up. I didn't label it because it's right there. Okay, continuing on page 32, now we're going to work backwards. We're not being given the coordinates. We just have to actually find them. Okay, so for example, A, we start at the origin and we move to the right, 1, 2, and then we move 1, 2, 3, 4, 5, 6 to find it. So it's 2, 6, as you can see right there. Okay? B, 1, 2, 3, that's B, 3, and we don't go up at all. So it's 3 and 0 because we don't go up, as you can see right there. 3, 0. Okay, let's find C, D together. Please write these down in your notebook as example 2, page 32, okay? So that I know that you're keeping track of what we're doing. So 2C would be, well, it doesn't go at all into the x-axis. You see that? It just stays right at the origin. So that's going to be 0, but it does go up 2 in the y. So now let's look at D. D is all the way over here. So we go 1, 2, 3, 4, 5, 6 on the x, 6, and 1, 2, 3 on the y. So it is 6, 3, as you can see. These will be a key answer, and I'm going to challenge your artist skills by seeing how well you draw this little guy bungee jumping. Let's call him Nicolo. Page 33. A set of ordered pairs such as 2, 3, 3, 5, 4, 1 is a relation. Now you can see, boys and girls, there's really no proportional relationship there. So it's a non-proportional relation, but it's still a relation. A relation can also be shown in a table or a graph. The domain of the relation is the set of x coordinates. Okay, this would be known as the domain. And the range of the relation is the set of y coordinates. This would be the range, how high it goes, how low it goes. And when you organize them, you see that 2, 3, and 4 are right here, 2, 3, and 4 in the x. And you can see that in the y we have 3, 5, and 1, 3, 5, and 1. Okay, so this is your domain and this is your range. Okay, and this is how we organize the data. Express the relation 0, 2, 1, 4, 2, 5, 3, 8 as a table. Then determine the domain and range. Okay, so we have for our domain, we have all the x values, all the x coordinates. Okay, so we have 0, 1, 2, 3, 0, 1, 2, 3. There's our domain. The domain is 0, 1, 2, 3. And our range is 2, 4, 5, 8, 2, 4, 5, 8. You can see, and the range is 2, 4, 5, 8. This, boys and girls, I would like you to do using this data in your notebook. Express the relation 2, 4, 0, 3, 1, 2, 1, 1 as a table, then determine the domain and the range. Okay? Well, if you have something like this, then you are correct. So we take the x-axis to 0, 1, 1, 2, 0, 1, 1, and the y-axis, which is your range, okay? And it should look like this. Now, please, boys and girls, I want you to draw this exact same thing in your books and put a star right next to it because it is a key answer. Now, please, give me this statement right here. Tell me which one is my domain and which are my range by writing it right next to it. You go ahead and do that. I know you can do it on your own. Okay. A seahorse swims at a rate of about 5 feet per hour. Make a table of ordered pairs in which the x-coordinate represents the hours and the y-coordinate represents the number of feet. 1, 2, and 4. Okay, so here we have our domain and here we have our range. 1 hour, 5 feet. 2 hours, 10 feet. 4 hours, 20 feet. So for every hour we have 5 feet. And you can see how it's graphed. As you can see, it's been graphed already. So 1 is 5, 1 up to 5. Now we're not counting by 5s. The range has been set up here so that every square, every 2 squares we have 5. You see that? On the grid. So the range has been changed. It doesn't necessarily have to align with the lines. So 1 hour is 5 feet, 2 hours is 10 feet, and then 3 hours would be 15 feet, 4 hours is 20. And you can see that we have a straight line that goes right through the origin. This is what we would call a proportional relationship. Okay, continuing with the questions. I will do these with you. I'll show you my answer from the text so that you copy it down and you get an idea of how to do it when you do it on your own. 1 square mile is equal to 640 acres. 640 acres. So that's 1 square mile is 640 acres. Make a table of ordered pairs in which the x-coordinate represents the number of square miles and the y-coordinate represents the number of acres in 1, 2, and 3 square miles. Okay, so we need 1, 2, and 3 square miles, which will be our x-coordinates, and we have to increase by 640 acres each time. So for A, it's going to look like this. Our domain is 1 acre, 2 acres, 3 acres. 1 acre is 640, as stated here. 1 square mile, sorry, not acre. 1 square mile is 640 acres. 1 square miles is 640 acres. So then 2 would be double this, 1,280. And then 3, we would have to add another 640, so we get 1,920. And this is the table you need to have. Now, graph the order pairs. Please use some grid paper to graph it in your notebooks if you don't have grid paper, or simply draw one with your ruler. And it should look something like this. Okay, along the y-axis we have the number of acres, and along the bottom we have the square miles. Again, this is our domain and this is our range. We start with 1 square mile, okay, and we graph it to the approximate amount of 640. It's just over 500. You see that? Okay, and then we have 2 square miles and we graph it to the approximate 1,280 mark. Okay, it's less than 1,500. You see that? And then the 3 square miles will be 1,920, which is almost the 2,000 mark. Okay, I'd like to see this in your notebooks. Please, I will also be looking for my smiley face to know that you watched the video. Okay, after looking at the guided practice, I can tell that you will have no issues doing any of this. For number 1, you have to graph each ordered pair on the coordinate plane. So graph all of these and label them F, A, W, Z right on there. And then tell me what coordinates you have for J, K, L, M. Okay, J, K, L, M. Remember, x-axis first and then the y. So write them right next to each other. Express each relationship of, please, boys and girls, when you're writing these down in your notebooks as you're doing them, make sure that you write the number and you also write the question. Okay, I will be looking for that. Express each relation as a table and determine the domain and range. Simply put these as a x and y tables and tell me which one is the domain and which one's the range. Okay, do it for both. And then, as we finished with the example 4 in the previous page, okay, I want you to complete it all. You're going to bring all of this together to do these two. Okay, that's all for today. See you in class. Make sure to finish all of page 34.